carbon on your way back?
Carbon is like the only atom. Well, it's not the only one, but it's the best one. It's one of just a few atoms that have 4 electrons in its outer level. And so, if you draw a carbon here, it has 4 electrons it can share with other things. So, for instance, it could share the 4 electrons with hydrogen. Let's pretend it shares with hydrogen. There we go. Now we have a molecule called CH4, which is methane. Methane. And of course I draw it like a cross on the board, but the board is 2-dimensional. It's actually a 3-dimensional molecule. So in 3 dimensions it would look like a tetrahedron. Does anyone ever play jacks anymore? That was a big game when I was a kid. You know what a jack is?
Yeah.
Lands and you throw the ball up and scoop the jacks up. It would be shaped like that. Kind of like this. Or that's a model of it. But on the board you have to draw it like this. Anywho, it's that's methane. You use the prefix meth whenever you have 1 carbon.
So,
Ane means it's all single bonds. Methane. You have a question?
I do. Is
But-
it meth?
Like methamphetamines?
Is that based on?
Well, it's based on this. It has a, whatever the organic molecule is that gives you the high or makes you, your heartbeat or whatever, has the prefix meth before the name.
But it's a single carbon.
It's a, what's that?
It's a solo carbon. It's not.
Yeah, it's probably a methyl group attached to some other larger molecule. A methyl group is basically a CH3 group with this, that's a methyl group right there, with this 1 electron able to share with another molecule. So it's probably some big molecule with a methyl group attached to it, I would guess. You could probably look up the structure of it, look up the name of it.
C10H15N.
What is it?
C10H15N.
And what's the name of that?
Methamphetamine. That's all it says.
It doesn't have the actual organic molecule name. Now, let's say our carbon was 2 carbons instead of 1. Now, we're sharing. So methane was CH4. This molecule is ethane. And what would be the chemical formula? It's not CH4. What is it? Can y'all look at this molecule up here and see what it is? C2H6. That's ethane. So ane means it's single bonds between the carbon. If we put a double bond there, you know what we call it? Ethene. Ene means there's a double bond in the structure. And, of course, when there's a double bond in the structure, it's sharing 2 pairs of electrons, so it can't share these electrons down here with the hydrogens. Probably would look like that, actually. That's ethene, and it's C2H4. Isn't that interesting?
Mm-hmm.
Now, one molecule that y'all are familiar with, y'all are intimately familiar with, if we put the H's back, we make it a single bond, and over here, instead of an H, we have an OH group. An OH group. That's ethanol. Ethanol. Whenever you put an OH group, that makes it an alcohol. Have you ever heard of ethanol? That's the alcohol that's in alcoholic beverages. Beer, wine, tequila, bourbon, gin. You know, y'all know, just look in your back seat. Funny. It's funny because it's true. That's ethanol. Ethanol is also the same thing that's in rubbing alcohol. So why can't you drink rubbing alcohol? You know why? Because they put poison in it. You know why they put poison in it? Because then they don't have to be charged liquor taxes. Because you can't drink it. If it's something you can drink and get drunk off of, the law is you pay really high taxes on it. If they didn't poison the ethanol that's in your that's in rubbing alcohol, a thing of rubbing alcohol wouldn't cost 99 cents. It costs $20.99. Isn't that crazy? They have to put something extra in it, a poison, to make it poisonous so you can't drink it. It's crazy. The world is a crazy place. Because alcohol really doesn't cost that much. It's the taxes on it that do. You're learning about life.
If you were illegally making alcohol, you made a lot more profit.
Yes, that's what they did back in Prohibition times. Yeah. Yeah, they had stills. You ever heard of a still? Moonshiners? They make their own alcohol. It's not expensive. You put plants in a container and let them eat the sugars, and they'll spit out alcohol. If you put corn in there, you make bourbon. If you put rye in there, you make whiskey. If you put wheat in there, you make vodka, and so forth. Put cactuses in there, you'll make tequila. Isn't that cool? You can learn all about that. I took a class in college called Fermentation Lab. We learned all about that, and we made our own beer.
Mr. Willis.
Did you drink it?
We drank it.
Oh, boy.
It was terrible.
Have you seen the video? There's like a tree in Africa where the fruit ferments on the tree, and like giraffes and elephants all eat it.
And they get drunk?
They get drunk.
Really?
It's-
Yeah, I hadn't heard that. Pretty cool. Look, you can see the double bond there in ethene, the double bond in the middle, and only 4 hydrogens. Remember, when you put a double bond on something, it removes some of the hydrogens. That's going to be important later when we start to learn the structure of these organic molecules. Now, we can add more and more carbons. We can take this off, keep adding more and more carbons, and make a long chain. So, methane is 1 carbon, ethane is 2, 3, do you know it? Prop means 3, propane, you ever heard of propane? 4 is bute, bute means 4, butane, you ever heard of butane lighter? That's butane is the fuel that's in a lighter. Pentane is 5, hexane is 6, heptane is 7. Those aren't too popular, but you've probably heard of octane before. High octane gasoline. It's got a lot of octane in it. Something like 93% of the gas is octane. Have you ever seen the numbers on a gasoline thing? It says 93 or whatever.
Yeah.
That's a number saying the amount of octane in the gas. The more you have, the kind of purer it is, purer it burns. I don't think it's actually a percentage because it can go over 100, I think. I'm not sure exactly what it is. Maybe it's weight per liter. I don't know. But anyway, this is organic chemistry. If you take organic chemistry in college, you have to learn how to name things. Now, one thing about a carbon chain is it can actually circle around and bond back to itself. It can make like a hexagon, or an octagon, or a pentagon, and go around and bond to itself. And that's a ring structure. And you can see we call it cyclo if it goes around in a ring and bonds to itself. Cyclopentane, cyclohexane. If you put a bunch of double bonds in it, it's called a benzene ring. Benzene rings are found in aromatic compounds. You know what aromatic means?
Never heard of it.
Aroma. Have you heard that word, aroma?
No good.
What's that mean, an aroma?
It's no good.
It smells good.
It's no good.
If you put a benzene ring on a molecule, it'll make it smell good.
So, why have we evolved to think benzene smells good?
That's a good question. It must be in some compounds that are good for you, I guess.
This isn't glucose very...
It's not the only thing that smells good, but they're aromatic compounds have a kind of a cool smell.
Isn't glucose very similar chemically?
Yes.
Do things that contain high amounts of
Glucose is just basically it's a cyclohexane, but you put a lot of oxygens in the structure too. Instead of that carbon there, there's an oxygen there. And every carbon has an OH group as well as an H attached.
So,
And then you have another carbon group sticking off. So that's this right here. That's galactose. That's glucose right there. Bam, glucose.
so Mr. Willis.
Yes.
So do things that contain lots of glucose also contain lots of benzene?
No, not necessarily. And by the way, benzene doesn't necessarily smell good. It's just smelly. Some smell good, some smell, bad. I don't know. But aromatic means it has a big smell to it. You need to know what an isomer is. An isomer is the same chemical formula, but a different structure. We call it an isomer. So let me give you an example. There we go. What is that? What would we call that?
Butane.
Butane. I like the way you sounded that out.
Thank you.
First you were thinking 4 is but, all single bonds is ane, butane. Now if you were to take this carbon group right here and remove it, it's a CH3 group. We remove it, we remove this hydrogen, move that hydrogen over there, and put the CH3 group that I just was talking about down here. It's the same formula. They're both C4H10. But they're different structures. And they have different properties when they have different structures.
No, I
We
see.
call those isomers.
Wait.
And you can see here, there's a C4H10, and there's another way to look at C4H10. Yes?
How do you write the chemical formula of one thing if it's the same as another thing?
You just write them both the same.
But how do you know the difference?
You don't by looking at the formula.
Okay.
You only know by looking at the structure.
Got it.
Do it, Carter. Carter, are you going to be an organic chemist?
Probably not.
So we call those isomers, they have different structures. These are called geometric isomers. They have a different structure too, but it happens to be in the way that the methyl groups are pointed. So in this, look at this structure right here. There's a double bond in the middle, and both methyl groups are pointing down. That's a methyl group, that's a methyl group. They're both pointed down. But in here, over here, one methyl group goes down and the other goes up. We call this configuration a cis configuration. Cis is when they're both pointed in the same direction. We call this a trans configuration. Trans, they're pointed in the opposite direction. Cis versus trans. It's still the same formula. It's still C4H8.
What's the difference then?
Sometimes they have different properties if they're pointed different ways. We've got a couple up here, actually.
What causes them to be different?
Often the way they're put together, there are enzymes in cells that put things together. It'd be like, I'm going to stick it on here, I'm going to stick it on here. One enzyme sticks it on here, the other enzyme sticks it up there. And they might have different properties. This is called glucose. That's the familiar blood sugar. This is called galactose. And if you look at this OH group right here, in this molecule, this OH is going down. In this molecule, that OH is going up. That's the cis configuration. That's the trans configuration. Glucose has the trans. Galactose has the cis. They're just slightly different sugars. Little differences make things. This is blood sugar. This is not, there's not much of that in your blood. How about an enantiomer? Enantiomers are mirror images of each other. So, here, the bromine comes off here. Chlorine, fluorine, and hydrogen. Here, the bromine's on the other side. They're the same formula, but they're like mirror images of one another. Sometimes enantiomers have the exact same properties, and sometimes they're different. Depends on the molecules. A lot of times it doesn't make much of a difference, but in some ways it does. Are y'all digging organic chemistry?
Yeah.
Can you say enantiomer? All at the same time?
Enantiomer.
That was all right. Wasn't that great? It's a fun word to say, enantiomer. This is a space-filling model. This is, if you could actually see small enough to see the atoms, this is actually would be what it looks like. This shows the difference between a cis and a trans configuration on a what's it called, no, not an amino acid, it's a fatty acid tail. This fatty acid tail has the cis configuration, has the trans configuration. This fatty acid has the cis configuration, where they're going the same way. So let me go back. Remember, the cis configuration the two methyl groups here are both pointed down, and it makes the fatty acid, if there's a long chain here, it makes it turn. It gives it a bend. The trans configuration, if there's a chain of carbons coming along and then you got a double bond and the chain continues this way, you don't really see the bend. Well, that bend is real important. Do y'all remember some fatty acid tails are straight from regular bio, and then you have the bent kind, and the bent kind is the kind we have in the cell membrane, and it kind of kept the phospholipids apart from one another and spread out. You need that in a cell membrane, so you need the cis configuration, not the trans configuration. Cis, trans, cis, trans. You can do a TikTok. Telling you, make a lot of money on TikTok, I've heard. Like $4 million somebody made. Y'all know about this?
Yeah.
No, Isomer Is.
The Addison girl made like 5 million.
I'm gonna do
A day?
No, I don't know.
There,
They make
there's
a lot.
500 grand I just
They
made.
make like 67,000.
Put that on TikTok, 500 grand.
You make more Charlie or
Addison.
She's over 8.
Oh look, Enantiomers. The D form and the L form. The L form over here can help build a protein. This form cannot. Y'all know what a protein is, right? It's a chain of amino acids. That's an amino acid right there. And that's an amino acid. Remember the amino group and the acid group and the R group? Y'all remember that? We're going to learn about this later. We'll get to it later if you don't remember it. I think they look like little dogs. You can name your dog Alanine. Here, Alanine. You know, because it looks like it. You see? Unless he's facing this way. You can name him you can name him Dalanine or Lalanine. Depending on which way he's facing when you buy him.
Dow for short.
Yeah. Give me good dog names. You know what I want to name my next dog? I want to name him Peeve. That way he's my pet peeve.
Oh, that's so
Do you have a dog, Mr.
I don't. I've got 2 fish though.
Nice.
What are their names?
I don't have names. I'll let y'all name them. How about that? These are functional groups. Functional groups are groups that attach to carbon chains. And I'll tell you the important groups. Hydroxyl, that's an important group. That's an OH group. You need to know that. A methyl group, that's important. That's just a CH3 group. Oh, and by the way, when you see the R stands for the rest of the molecule. It's like a big long carbon chain is the R, and then there's the group that sticks off of it. These functional groups can change molecules. A carbonyl group is a double bond O. We aren't going to run into those. I've never heard them ask about carbonyl groups. A carboxyl group is a COOH. You will have to know that one. That's every amino acid has a carboxyl group. An amino group is NH2. You got to know about the amino groups. Phosphate groups, you got to know about those. That's a phosphate with 4 oxygens coming off of it. And a sulfhydryl group, you got to know that. So you pretty much have to know them all, don't you? Maybe except the carbonyl.
Wait.
I'm not going to wait.
Okay, that's okay.
You good? Yeah. This is all in your book.
Wait, what's the R group called?
The R group is the rest of the molecule. Could be anything. It's usually a bunch of carbons. Could be a ring, could be a benzene ring, the R group, who knows what it is. How much do we have left? Oh, this is it.
Want to go back?
These little dots here are hydrogen bonds. We're going to learn about that. That's a bond. We learned about that already. Didn't we learn about hydrogen bonds? When we did water. Okay. All right, well, that's basically the end of chapter 2. Could be a quiz on that one day. I didn't get to do everything in the chapter, so make sure you read it. Take good notes. I need my wipers to start wiping, and the rest of y'all can leave. And this is the last day for these wipers for a long time.